Welcome friends to the lecture on Civil Engineering Simplified. So this time we are going to learn about the calculation of bending moment and shear force. BM is for bending moment, SF represents the shear force for a simply supported beam carrying UDL. UDL means it is uniformly distributed load. This regarding the type of loadings we have already seen in our previous lectures. So now I am not going to elaborate against this, but I would like to tell that UDL means it is uniformly distributed load. To understand this better, let us take a simply supported beam of certain span. I am going to write a schematic sketch of simply supported beam here. Let us consider a span of 8 meters. Let's consider a UDL acting on the beam. As I said, UDL is a uniformly distributed load of intensity 2 kN per meter. As the load is uniformly distributed, it is always represented per meter run. So I'll call, as we have seen in our previous cases, I will represent the left support as A and the right support as B. Now let us proceed. As we have seen in the previous cases, we will calculate the support reactions A and B, which we represent as RA and RB. So we can proceed like we did in the last previous cases. I will take moments about A. If I take moment about A, RB is the reaction at point B, which is at a distance of 8 meters. So this force or this moment, actually, as you can see, this load is acting upwards, hence this causes an anti-clockwise moment, which should be equal to the clockward or the clockwise downward moment which is acting on a beam, which is 2 kN per meter, which is acting over a span of 8 meters. So this is the total load acting on a beam. The resultant or the line of action of this force acts at mid-span, which is at 4 meters or L by 2. L by 2 in this case is 4 meters. Hence, this is the total force multiplied by the perpendicular distance, which is 4 meters in this case. So now let us simplify this equation. So 8 RB is equal to 2 into 8 into 4, which is 64 kilonewton. Hence we can always calculate RB, which works out to 8 kilonewton. This is the value of RB. We can calculate RA also. As I said, we will apply equation sigma V equals 0, hence which implies to RA, the summation of the vertical reactions acting on the extreme ends should be equal to the total downward load. Total downward load is 2 kN per meter multiplied by total span of 8 meters. Hence, now we have already calculated the RA, or rather RB. RA plus 8 kilonewton must be equal to 16 kilonewton, which boils down or which simplifies to calculation of RA, which is again equal to 8 kilonewton. So now the first step is over. Hence we write these values. RA is equal to 8 kilonewton and RB kilonewton. Now, having calculated RA and RB, we can always write or find out the shear force diagram for this, which is the first case. I draw a simply a simple horizontal line to represent the datum. So as we have discussed earlier, while writing the shear force diagram, the RA at the extreme left hand is acting upwards. Hence, I represent or draw a line equal to 8 kN or 8 units onto the left hand side. After that, we find the UDL which is acting downwards. Hence, this shear force diagram dips down towards the horizontal line at the center. Until center, it becomes 0. And again, it continues down because the downward force is acting again onto the right hand side of the midspan of the beam, which continues further, meets the extreme right end over here. Here we have got upward reaction RB, hence it joins this horizontal line over here. Since this portion of the triangle is above the horizontal line, we represent this by a plus sign, and this, since it is going down, we represent it by minus. So this is the shear force diagram. So after calculation of reactions, we are going to represent the shear force diagram here. So now let us see, the next step is, I will call this as say 1. Step 2 would be the calculation of the bending moment. See, at this point I would like to tell you, for a case of a simply supported beam which is subjected to UDL, the maximum bending moment occurs where the shear force changes its sign. In this case, you can see that this carries a plus sign which is dipping down, which meets the horizontal line exactly at midspan of the beam, that is at 4 meters. This distance is at 4 meters, which is half the span of the beam. Hence, if you want to know where the maximum bending moment occurs, it is at this point only, where the shear force becomes 0 or where it changes the sign. At that point, the bending moment will be maximum. Since we know that where this bending moment occurs, or where the bending moment is maximum, we will calculate the maximum bending moment at this point, which is at half the span of the beam. So I will call this point, say, on the beam as C. We have called the extreme supports as A and B. The midpoint I am calling it as, say, C. So at this point C, let us calculate the moments, find out what is the value of the moment. Take moments about C. Let us take moments about point C. When we take moment either from point C, we can take the moments to the right or onto the left hand side, because the whole system is in equilibrium. Now I will take the moments onto the left hand side. So MC, I will represent the moment about C as MC, which is, we have got the reaction which is acting upwards, RA, which is acting at a distance of 4 meters from point C. This is a clockwise moment. I am representing the positive side. The total downward, there is a total downward acting load also here, which is the UDL. This is acting anti-clockwise, hence I represent it by my minus. The intensity of UDL is 2 kilonewton per meter, acting over a span of 4 meters. From point A to point C, this is 4 meters. So this UDL, or the resultant of this UDL, acts at half the distance of 4 meters, or the half the span of the beam, which is 2 meters from point C. Hence, you multiply this by 2 meters. The definition of moment is force into perpendicular distance. Hence, this is the total force multiplied by the perpendicular distance. We know the value of RA, which we have calculated earlier, which is 8 kilonewtons here. 8 kilonewton multiplied by 4 meters minus 2 into 4 is 8, 8 into 2 is 16. 16 kilonewton meter. As you can see, kilonewton multiplied by meter is kilonewton meter. Hence the units for moment is always kilonewton meter. So here it becomes 32 kilonewton meter minus 16 kilonewton meter. Hence, which works out to 16 kilonewton meter is the moment at C. Okay. So this again, we can draw the bending moment diagram for this. As I have told earlier in my earlier lectures, for a simply supported beam, at the extreme ends, the moment would become 0, and in this case, since this is a UDL, the bending moment diagram would be in the form of a parabola. I will draw a horizontal line again. I will extend the point where the shear force changes its sign. That is the half or the midspan of the beam. Extend this line. So this is the point where the maximum bending moment occurs, and from 0 to 16 meters on to the left hand side, continuing on to the right hand side, this again becomes 0 here. Since this UDL causes a sagging moment, suppose this causes the deflection of the beam deflects like this downward. This is called as a sagging moment. Whenever a sagging moment occurs, the bending moment diagram we represent by a positive sign. This I will call as a BMD. So this is a simple way, this is a plus sign. This is a simple way of drawing a bending moment diagram for a simply supported beam carrying UDL. Now let us see, as I was just saying that for a simply supported beam, the moment at the support is always 0. Let us just verify one case. I will try to take moments about point A to prove that the moment at this point is 0 as we are represented here. So let us do a simple calculation. Take moment about A. If we take moment about A, we have got this reaction RB which is acting anti-clockwise, and we have got a clockwise moment due to UDL for the whole span. So first of all, let us see this one. This is a clockwise moment, so I will consider this first. The intensity is 2 kilonewton meter per meter acting over a span of 8 meters. This is the total load multiplied by the perpendicular distance, which is half the span, that is 8 by 2. This is, as I said, is a clockwise moment. We have got an anti-clockwise moment in this direction, which is the reaction RB, which is nothing but RB multiplied by the perpendicular distance, which is 8 meters. So now let us simplify this. It is the 4 into 8 is 32, 32 into 2 is 64 kilonewton meter minus the value of RB is 8 acting at a span of 8 meters. So this is also 64, this is also 64. So the net moment is 0. So that is why in a simply supported beam, extreme ends do not have any moment and the value will be 0. So this is a simple way of illustrating or calculating the bending moment and shear force of a simply supported beam carrying UDL. I hope you all delighted or understood this better. If you have any queries or comments, please mail it to the email ID in the comment box below. Thanks for watching. Keep watching more and more videos. Thank you.